A mysterious wall of superheated plasma sits at the edge of our solar system right now, burning at temperatures that would vaporize any known metal in seconds, and scientists just found proof it exists because of two tiny spacecraft that left Earth decades ago carrying golden records meant for aliens. The Voyager probes discovered something nobody expected when they reached the furthest edges of space, where our sun's influence ends and the vast emptiness of the galaxy begins. This wall glows at 50,000 degrees, which is hotter than the surface of our own sun, and it wraps around our entire solar system like a bubble made of fire. But here is what makes your skin crawl. We had no idea this thing was out there until very recently, and what it means for Earth and everything we thought we knew about space just got flipped upside down. The story starts in 1977 when NASA launched two robot explorers into space on a mission that seemed impossible at the time. Voyager 1 and Voyager 2 left Earth carrying cameras, scientific instruments, and those famous golden records that had sounds and pictures from our planet, including music, greetings in different languages, and even the sound of a mother kissing her baby. The plan was simple: fly past Jupiter and Saturn, take some pictures, and see what happens next. Nobody at NASA really believed these machines would last more than 5 years in the harsh environment of deep space, where radiation, tiny space rocks, and the freezing cold destroy everything eventually. But something amazing happened that changed space exploration forever. These two spacecraft just kept going and going like the toughest robots ever built. They flew past Jupiter and saw storms bigger than Earth itself. They discovered new moons around Saturn and found volcanoes on a moon called Io that shoot lava hundreds of miles into space. Voyager 2 became the only spacecraft ever to visit Uranus and Neptune, showing us those distant ice giant planets up close for the first time in human history. The pictures they sent back looked like paintings, with Neptune's bright blue color and Uranus tipped over on its side, spinning like a broken top. Scientists celebrated every new discovery, but they had no idea the best part was still coming decades later. After finishing their tours of the planets, both Voyagers kept flying outward into space, heading for the edge of everything we call home. Our solar system is not just the sun and planets. It extends way beyond Pluto into a region that most people never learn about in school. The sun constantly shoots out particles called the solar wind, billions of tiny bits of matter flying away from the sun in all directions at speeds over 1,000,000 miles per hour. This solar wind creates a huge bubble around our solar system called the heliosphere. And inside this bubble, we are protected from dangerous radiation that fills the rest of the galaxy. Think of it like Earth's atmosphere protects us from space, but bigger, way bigger, extending billions of miles past the last planet. The Voyagers were heading toward the edge of this bubble, and scientists wondered what they would find when they got there. Would the solar wind just slowly fade away? Would there be a clear boundary, like a fence? Nobody knew because no human-made object had ever gone that far before. The spacecraft traveled for decades, moving about 35,000 miles per hour, which sounds fast until you realize how big space really is. Every day they got further from Earth, so far that radio signals from the Voyagers take over 20 hours to reach us traveling at the speed of light. Imagine sending a text message and waiting almost a full day for it to arrive. That is how far away these machines are right now. In 2012, something incredible happened. Voyager 1 started detecting strange changes in the space around it. The solar wind particles that had been hitting its instruments for 35 years suddenly dropped to almost nothing. At the same time, different particles started showing up, particles that came from outside our solar system, from the galaxy itself. Scientists realized Voyager 1 had crossed the boundary and entered interstellar space, becoming the first human object to leave the solar system. It was like crossing from one country into another, but instead of countries, it was our cosmic neighborhood and the vast unknown beyond. The news made headlines around the world, but most people did not understand what it really meant or what Voyager found at that boundary. 6 years later, in 2018, Voyager 2 also crossed into interstellar space at a different location, giving scientists a second set of measurements from the edge. Both spacecraft sent back data that confused everyone at first. The boundary was not smooth or simple, it was complicated and violent. The temperature suddenly jumped to incredibly hot levels, and the particles were moving in unexpected ways, crashing into each other and creating chaos. Scientists started analyzing the data more carefully using computers to model what was happening. And that is when they discovered the wall. This wall is not solid like brick or metal. It is made of plasma, which is the fourth state of matter after solid, liquid, and gas. Plasma forms when regular gas gets so hot that electrons break free from atoms, creating a kind of electric soup that glows and conducts electricity. The wall exists at the very edge of the heliosphere, where the solar wind from our sun crashes into the interstellar medium, which is all the gas and dust floating between stars in the galaxy. When these two things collide head-on, they create tremendous friction and heat, like rubbing your hands together really fast, but multiplied by billions. The temperature at this collision zone reaches 50,000 degrees Fahrenheit, which is completely insane when you think about it. To understand how hot that really is, consider that the surface of the sun is about 10,000 degrees. This wall is 5 times hotter than that. Steel melts at around 2,500 degrees. Diamonds, which are the hardest natural material, turn to vapor at about 6,900 degrees. At 50,000 degrees, atoms are moving so fast they smash into each other constantly, and everything becomes plasma, a state where matter breaks down into its most basic parts. The wall glows with ultraviolet light that we cannot see with human eyes, but the Voyager instruments detected it clearly. Scientists call this region the heliopause, and it basically marks the spot where our sun's power ends and interstellar space begins. But here is where things get really weird and a little bit scary. The wall is not staying in one place. It moves and changes size, like a living thing breathing in and out. The sun goes through cycles of activity, sometimes shooting out more solar wind and sometimes less. During solar maximum, when the sun is very active, the solar wind pushes harder and the wall moves outward, expanding our bubble. During solar minimum, when the sun is quieter, the pressure drops and the wall contracts, moving inward. This means the edge of our solar system is not fixed. It wobbles back and forth by billions of miles. Right now, based on recent measurements, the wall sits roughly 11 billion miles from the sun, but that distance changes. Scientists discovered something else that nobody predicted. The wall is not the same thickness everywhere. In some places, it is thin and weak. In other places, it is thick and strong. The shape is not a perfect sphere, but more like a dented ball or a teardrop with a long tail stretching behind us. This happens because our entire solar system is moving through the galaxy at 45,000 miles per hour, heading toward a constellation called Ophiuchus. As we plow through interstellar space, the stuff in front of us piles up, creating a thicker wall in that direction, while the stuff behind us spreads out thinner. It is like how water builds up in front of a boat, but spreads out behind it in a wake. The discovery of this wall answered some questions but created many more. Scientists now wonder what would happen if the wall failed or broke down. Remember that inside the heliosphere, we are protected from galactic cosmic rays, which are dangerous high-energy particles zipping through space at nearly light speed. These cosmic rays come from exploding stars called supernovas and from other violent events in the galaxy. They can damage DNA, destroy electronics, and make space travel incredibly dangerous for humans. The wall and the heliosphere keep most of these cosmic rays out, but some still sneak through. If the wall weakens significantly, more cosmic rays would reach the inner solar system and eventually Earth. This actually happened before in Earth's history, though scientists are still debating the details. About 13,000 years ago, Earth's climate changed rapidly, and many large animals went extinct, including mammoths and saber-toothed cats. Some researchers think the solar system might have passed through a dense cloud in the galaxy around that time, which compressed the heliosphere and let more cosmic rays reach Earth. These cosmic rays could have affected the atmosphere, increased lightning strikes, started wildfires, and even damaged the ozone layer that protects us from ultraviolet radiation. The evidence is not totally clear yet, but it shows that what happens at the edge of the solar system billions of miles away can potentially affect life on Earth. Another mystery scientists are working on involves how the wall formed in the first place. Our sun is not unique. Almost every star has its own bubble and its own version of this hot wall, where its stellar wind meets interstellar space. But stars come in different sizes and temperatures, which means their walls must be different too. A giant blue star that burns hot and bright probably has a much bigger bubble and a more powerful wall. A tiny red dwarf star probably has a smaller bubble and a weaker wall. Understanding our wall helps scientists figure out what is happening around other stars and whether their planets might be protected or exposed to dangerous radiation. The Voyagers are still sending data back to Earth, even though they are now over 14 billion miles away and counting. Their power is running low because they run on nuclear batteries that slowly decay over time, producing less electricity each year. NASA engineers have turned off most of their instruments to save power, but a few key sensors remain active, including the ones measuring particles and magnetic fields. Scientists estimate the Voyagers might keep working until around 2025 or 2030, if they are lucky. After that, the spacecraft will go silent and drift through the galaxy, as ghost ships carrying those golden records as the only proof that humans once existed and reached out to touch the stars. But the data already collected will keep scientists busy for many more years. Every measurement from the wall region gets studied in detail using supercomputers to create simulations of what is happening out there. These simulations show a complex dance of magnetic fields, plasma waves, and particle flows that twist and turn in ways that seem almost alive. The sun's magnetic field extends beyond the planets and gets dragged by the solar wind until it reaches the wall, where it tangles with the galaxy's magnetic field, creating knots and loops. Sometimes these fields reconnect, suddenly releasing huge bursts of energy that heat the plasma even hotter and create shock waves that ripple through space. One of the most surprising findings involves something called pickup ions. These are atoms from interstellar space that drift into the heliosphere and get grabbed by the solar wind. Once captured, they get accelerated to very high speeds and slammed into the wall from the inside, adding more energy and heat to the collision zone. It is like adding fuel to a fire, making it burn hotter and brighter. The Voyagers detected huge numbers of these pickup ions, especially near the wall, proving that the boundary between our solar system and the galaxy is not a simple dividing line, but an active mixing zone where material from both sides comes together. Scientists also found that the wall vibrates and wobbles, sending out ripples, kind of like dropping a stone in a pond, creates waves. These ripples travel both inward toward the sun and outward into interstellar space, carrying information about what is happening at the boundary. Some of these waves might eventually reach Earth, though very weakened by the time they arrive. Detecting these waves from Earth is incredibly difficult, but researchers are building new instruments to try, because the waves could tell us about changes in the wall happening right now instead of waiting decades for a spacecraft to get there. The temperature of 50,000 degrees also tells scientists something important about energy. Heating plasma to that temperature requires tremendous power, and that power has to come from somewhere. When the solar wind particles traveling at 1,000,000 miles per hour crash into the nearly stationary interstellar gas, all that motion energy converts to heat energy. It is the same principle as friction, but on a scale that boggles the mind. Every second, billions of tons of solar wind slam into the wall, releasing energy equivalent to millions of nuclear bombs, but spread out over an enormous area. This constant collision has been happening for billions of years, ever since the sun formed and created its bubble of influence. Looking to the future, NASA and other space agencies want to send new missions to study the wall and the heliosphere boundary in more detail. The Voyagers only crossed in 2 spots, and they carry old technology from the 1970s. A new mission with modern instruments could map out the wall in 3 dimensions, measure its temperature more precisely, and study how it changes over time. One proposed mission, called the Interstellar Probe, would travel even faster than the Voyagers, using a gravity assist from Jupiter and possibly new propulsion systems. It could reach the wall in just 15 years instead of 35 and carry instruments designed specifically to study the boundary region. Understanding the wall also matters for human space exploration beyond Earth. If we ever want to send astronauts to Mars or further into the solar system, we need to know about the radiation environment they will face. The wall keeps out the worst galactic cosmic rays, but inside the heliosphere, we still face radiation from solar flares and other sun events. Finding the right balance and knowing what protection is needed requires detailed knowledge of how the heliosphere works and how effective the wall is at shielding us. Some scientists think future long-distance space missions might need special shielding or timing to avoid periods when cosmic ray levels are higher. The discovery also connects to the search for life beyond Earth. When we look for planets around other stars that might support life, we need to know if those planets are protected by their star's bubble and wall. A planet sitting inside a strong heliosphere might have a much better chance of developing life because dangerous radiation is kept at bay. A planet outside its star's protective bubble, or around a star too weak to create a good bubble, might be constantly bombarded by cosmic rays, making life almost impossible. The wall our Voyagers found shows us what protection looks like and helps astronomers know what to look for around other stars. There is something deeply moving about the fact that 2 small machines built by humans over 45 years ago are still out there exploring and teaching us about the cosmos. The Voyagers were built before personal computers, before the internet, before smartphones, using technology that seems ancient now. Yet they survived the journey through the solar system, past the planets, and into the space between stars. They faced the wall of superheated plasma and lived to tell the story. The engineers and scientists who built them are mostly retired now, and some have passed away, but their creation continues the mission, carrying humanity's curiosity into the unknown. The wall itself stands as a reminder of how much we still do not understand about the universe. For most of human history, people thought the sky was a solid dome, with stars painted on it. Then we learned about planets and gravity and the vastness of space. We discovered our sun is just one star among hundreds of billions in our galaxy, and our galaxy is just one among trillions in the universe. Each discovery makes us smaller and the cosmos bigger. Finding this wall of fire at the edge of our solar system shows that even our own cosmic backyard holds secrets and surprises we never imagined. It proves that exploration always rewards us with new knowledge and often with new mysteries to solve. Some researchers wonder if the wall could be used somehow in the far future. Plasma at 50,000 degrees contains enormous energy, and if humans ever develop technology to harvest it, the wall could become a resource. This sounds like science fiction now, but so did landing on the moon before we did it, and so did the internet before it existed. Advanced civilizations, if they exist, might have learned to tap into the energy at the boundary of their star systems. It is fun to imagine, but also makes you think about what might be possible centuries from now if humans survive and keep exploring and inventing. The wall also raises questions about time. It took the Voyagers 35 years to reach the boundary, traveling at 35,000 miles per hour, which is 60 times faster than a speeding bullet. That means the wall is unimaginably far away from Earth, sitting at a distance that would take tens of thousands of years to reach if you were driving a car. The light from the sun takes over 17 hours to get there. When you look at the night sky, you are seeing stars as they were years or centuries or even thousands of years ago because their light takes that long to reach us. The wall exists right now in 2024, but the data we receive from the Voyagers about crossing it shows what the wall was like back in 2012 and 2018. In a very real sense, the wall is in our past, even though it exists in our present and will be part of our future, as long as the sun keeps shining. The magnetic fields around the wall create another fascinating puzzle. Earth has a magnetic field that protects us from solar radiation and creates beautiful auroras when solar particles hit our atmosphere. The sun also has a magnetic field that extends throughout the solar system and shapes how the solar wind flows. At the wall, these fields get compressed and stretched and tangled, creating a complex structure that scientists are still trying to map. Some models suggest the fields form a twisted braid pattern, while others show bubbles and loops. The Voyagers measured the field's strength and direction, but only at 2 points. So we are trying to imagine a huge three-dimensional structure from just 2 measurements, which is like trying to understand an entire forest by looking at 2 trees. Particle physicists are especially interested in the wall because cosmic rays that make it through can be detected on Earth using huge underground detectors. By comparing cosmic ray measurements on Earth with Voyager data from the wall, scientists can figure out how many cosmic rays the wall stops and how many sneak through. This information helps us understand fundamental physics and the behavior of particles at extreme energies that we cannot create in laboratories. Some cosmic rays are so energetic that they must come from the most violent events in the universe, like colliding black holes or exploding stars, and studying them teaches us about physics at the edge of what is possible. The shape of the wall changes depending on what the sun does. During solar maximum, the sun becomes more active with more sunspots, more solar flares, and more coronal mass ejections, which are huge bursts of plasma thrown into space. All this activity strengthens the solar wind and pushes the wall further out. During solar minimum, the opposite happens, and the wall moves inward. The sun follows an 11-year cycle from maximum to minimum and back, so the wall breathes in and out on this schedule. Right now, we are approaching solar maximum, which means the wall should be expanding. Future measurements might show how much it moves, and whether the movement affects anything in the inner solar system. Climate scientists have started looking at possible connections between the wall and Earth's climate. When the heliosphere shrinks and the wall moves inward, more cosmic rays can reach Earth. These cosmic rays might affect cloud formation in our atmosphere by ionizing air molecules, which could seed clouds. More clouds could change Earth's temperature and weather patterns. The evidence for this connection is still being debated, and many scientists are skeptical, but it represents an amazing possibility that events happening 11 billion miles away could influence the weather we experience on Earth. It shows how connected everything is in nature, even across vast distances of empty space. The wall glows in ultraviolet light that is invisible to human eyes, but we can detect it with special instruments. If you could somehow survive out at the wall and see ultraviolet light, you would see a faint purple glow surrounding the entire solar system like a giant bubble of light. Inside the bubble, everything would look different because you would be outside looking back at our sun, which would appear as a bright star among countless others. The planets would be invisible specks lost in the glare of the sun. Earth would be a pale blue dot, just like Carl Sagan described it, a tiny point of light carrying everything and everyone we have ever known. Standing at the wall, if it were possible, would give you a perspective on the universe that no human has ever experienced. Time is another strange factor at the wall. Because of the vast distances involved, the wall we see and measure today might be different from the wall as it exists right now. If something changed at the wall at this exact moment, we would not know about it for over 17 hours because that is how long it takes light and radio signals to travel that distance. This delay means we are always looking at the past when we observe distant objects in space. The nearest star beyond the sun is over 4 light years away, so we see it as it was 4 years ago. Distant galaxies appear as they were millions or billions of years ago. The wall is close by comparison, but still far enough that we experience a time delay, making space exploration and astronomy a study of cosmic history as much as present reality. Engineers marvel at how the Voyagers have survived so long in an environment that destroys most technology. The spacecraft face extreme cold around -350 degrees Fahrenheit, except when passing near the sun. They get hit by tiny space dust particles traveling at high speeds, which can damage instruments. Radiation from the sun and from cosmic rays slowly degrades electronics over time. Yet the Voyagers keep working using technology from the 1970s that would seem ridiculously primitive today. Their computers have less memory and processing power than a modern electronic car key. They communicate with Earth using transmitters that produce only about 20 watts of power, which is less than a household light bulb. The fact that we can still hear their faint signals from over 14 billion miles away is itself an incredible achievement of engineering and science. The golden records carried by both Voyagers include sounds and images meant to represent humanity to any alien civilization that might find the spacecraft millions of years from now. The records have greetings in 55 languages, music from around the world including Bach, Mozart, Chuck Berry, and traditional songs from many cultures, sounds from nature like thunder, wind, and animals, and 116 images showing Earth, humans, and our scientific knowledge. The records are made of gold-plated copper and should last billions of years in the vacuum of space. They include instructions showing how to play the record and where Earth is located, though whether any alien could figure it out is unknown. The Voyagers will pass near other stars in tens of thousands of years, carrying these messages in bottles across the cosmic ocean. Scientists use supercomputers to model the wall and predict what might happen under different conditions. These simulations require massive computing power because they must track billions of individual particles interacting through magnetic fields and collisions. The models show that the wall can develop instabilities where parts of it bulge inward or outward, creating waves and ripples. Sometimes the wall can even develop holes or weak spots where interstellar material leaks through into the heliosphere. These simulations help researchers understand what the Voyagers measured and predict what future missions might find. They also help identify the best places to send new spacecraft to learn the most about the wall and the boundary region. The element composition of the wall tells scientists about both the sun and interstellar space. The solar wind contains mostly hydrogen and helium, with tiny amounts of heavier elements like oxygen, carbon, and iron. The interstellar medium has a similar makeup, but with slightly different ratios, and some molecules like hydrogen molecules instead of individual atoms. When these materials collide at the wall, they mix together, creating a blend that the Voyagers detected. By analyzing which elements and isotopes are present, researchers can figure out the history of the sun and the galaxy, how stars have enriched space with heavy elements over billions of years, and what conditions exist between stars. Children learning about the Voyagers and the wall often ask whether the spacecraft will ever come back or whether we will see them again. The answer is no. They are gone forever, heading out into the galaxy, and will never return. In about 40,000 years, Voyager 1 will pass within about 1.6 light-years of a star called Gliese 445, which is not close at all in cosmic terms. Voyager 2 will pass near a star called Ross 248 in about 40,000 years as well. Eventually, both spacecraft will orbit the center of the galaxy, along with the Sun, and billions of other stars making a complete orbit every 225 million years. They will become permanent residents of the Milky Way galaxy, silent ambassadors from Earth, drifting through the void. The discovery of the 50,000-degree wall reminds us that space is not empty or boring, but filled with dynamic processes and extreme environments. Even the so-called empty space between stars contains gas and dust and magnetic fields and cosmic rays. The wall represents the boundary between two very different regions of space, and studying it helps us understand how stars interact with their surroundings. Every star creates a bubble, and therefore every star has its own wall, where its stellar wind collides with the interstellar medium. Our wall is the only one we can study up close right now, but learning about it teaches us about stellar physics that applies throughout the universe. Looking forward, the next few decades will bring more discoveries about the wall as scientists continue analyzing Voyager data and developing new theories. Already, researchers have published hundreds of papers about the heliosphere and its boundary using measurements from the Voyagers combined with observations from Earth and from other spacecraft like IBEX, which studies the boundary from inside the solar system. Each new paper adds pieces to the puzzle, helping us build a complete picture of this remarkable structure at the edge of our cosmic home. The work never stops because science always leads to new questions, even as it answers old ones. The wall exists right now, glowing at 50,000 degrees, wrapping around our solar system as it has for billions of years, and will for billions more until the sun eventually dies. It protects us from dangers we cannot see and shields Earth from radiation that would make life much harder, if not impossible. We owe our existence in part to this wall of fire at the edge of space, and now thanks to two small robots launched decades ago, we finally know it is there. The Voyagers gave humanity an incredible gift: knowledge about our place in the universe, and proof that we can explore even the most distant frontiers if we have courage and curiosity. The wall stands as a monument to the power of science and exploration, a reminder that the universe always has more secrets waiting to be discovered by anyone brave enough to look.